Their idea goes like this. Time, as it approaches the beginning, gradually turns into space. As if time has no edge, the same way the surface of a sphere has no edge. Ask yourself, if time has no starting point, only a smooth transition, was there ever really a moment before? Another idea belongs to Roger Penrose himself. He called it conformal cyclic cosmology. Penrose proposed that our universe isn't the first, that before it there was another universe, one that expanded for so long and so evenly that it lost all sense of scale. And at that moment, the infinitely distant future of one universe became the Big Bang of the next. He published this hypothesis in 2010. Part of the scientific community remains skeptical of it, but it remains one of the few ideas that tries to give a physical, not just mathematical, answer to the question, what came before? A third idea came from Alan Guth in 1980. He proposed the theory of cosmic inflation, the ultra-fast expansion of the universe in its first fractions of a second. Inflation explains why the universe looks so uniform in every direction we look. But inflation has an unexpected consequence. If inflation ever started, it may never fully stop. In some regions of space, it halts, and a universe like ours is born. In others, it goes on forever. This led physicists like Andrei Linde to the idea of eternal inflation, an infinite number of universes being born again and again, each with its own Big Bang. If that's true, then the question isn't what came before the Big Bang. The question is, how many Big Bangs are happening right now in places we will never see? This isn't science fiction. It's a mathematical consequence of equations that perfectly predict what we already observe. The cosmic microwave background, discovered by Arno Penzias and Robert Wilson in 1965. The cosmic microwave background is the cooled light of the earliest universe, still arriving after almost 14 billion years. It surrounds Earth from every direction, like the echo of a first cry. Every time an old television caught static between channels, part of that noise was light from almost the very beginning of time. Think about that. Ordinary household static contained a fragment of the moment of creation itself. And yet, for all these theories, science doesn't have a final answer. The no-boundary model, Penrose's cyclic cosmology, eternal inflation, all of them are mathematically consistent. None of them has been confirmed experimentally beyond reasonable doubt. Maybe the issue isn't that we lack an answer. Maybe the issue is that the question is being asked in a language that doesn't apply to this part of reality. We're used to thinking causally, first one thing, then another. But time isn't a universal ruler that has always existed everywhere. Time is a property specifically of our universe. Asking what came before time is like asking what's south of the South Pole. Maybe the most honest answer, the one physics still isn't ready to give, is, we don't know. And that's not a failure of science. It's the frontier where science currently stands. Every generation of physicists has pushed that frontier further. Newton explained the motion of the planets. Einstein explained space and time themselves. Perhaps the next Einstein hasn't been born yet. Until then, we remain creatures standing on the shore of time, staring toward the place where the map ends, trying to understand if there's something more out there. Or perhaps the question itself loses meaning the moment we ask it. You are living inside 13.8 billion years of history. But maybe inside isn't the right word. Maybe you yourself are part of that very fabric. The fabric that once didn't exist at all and then simply began to be. But here's a question physics still can't close. If the universe began at some point, does that mean it will end someday? There are several scenarios, and none of them sound like they belong in a movie. One is called the Big Freeze. The universe keeps expanding forever. Stars go dark one by one, black holes slowly evaporate, and an endless, cold, empty silence sets in. Another is called the Big Crunch. Expansion eventually stops and reverses, and all of space collapses back into a single point. the same way it once came out of one. The third, the strangest, is called the Big Rip. If dark energy strengthens over time, expansion could accelerate so much that it tears apart galaxies, stars, planets, and eventually even atoms themselves. Which of these endings awaits us depends on one quantity we still don't fully understand: the nature of dark energy, which makes up almost 70% of the entire universe. We don't know what it is. We only know that it's the thing that will decide how all of this ends. So maybe the right question isn't, what came before the beginning? Maybe the right question is, will anything be around to see the end? And if space one day contracts back into a point, preparing to give birth to a new universe, will there be anything inside it capable of asking the same question all over again?